solve these problems. So I know many of you are very talented and can do the guess and check, trial and error, or have some other systems. But we are going to use the algebraic systems of equations here. So there's 13 animals in a barn. Some are chickens, some are pigs. There's 40 legs in all. How many of each animal are there? So first we're going to assign variables for the two unknowns. How many of each animal are there? So I'm looking for pigs and chickens. So P is going to be, I'm going to use the number of pigs. You could use X's and Y's if you want. And I'm going to use C for the number of chickens. So it's good to slow down and label what your variables are going to stand for. All right, now I need a system of equations. So there's two things happening in this problem. One has to do with the number of animals that are there, and one has to do with the number of legs that are showing up there. So if there's 13 animals at the barn, what's one equation we could use?
P plus C equals 13.
All right, P plus C is 13. Now there's 40 legs in all. We have to figure out how to use that piece of information. Okay.
You could do 4P plus 3C equals 40.
Well,
2C.
okay. So pigs have 4 legs, chickens have 2 legs.
40.
Oh, 40, thank you. All right. So, and again, you could have used the x's and y's. X plus y is 13, or x plus 2y is 40. You still technically are looking at lines. They just mean something this time. So, now you can solve the system either by elimination or substitution. I'm hoping you hooked on to elimination. Somebody suggest something to multiply the top equation by. All right, Nelson.
You subtract the two.
Oh, wait, no. Here's my question. What could I multiply the top equation by?
Oh.
If we're going to use elimination.
Yeah.
So there are other ways. I just wanted to practice the elimination method one more time. 2? All right. So if I multiply this by 2, is this going to disappear?
No.
So let's multiply by negative 2. Just so it's sort of all done in one step. So that's going to be negative 2p minus 2c equals negative 26. Make sure you distribute your negative 2 into everybody. Our second equation is still 4p plus 2c is 40. So when I put those together, the c's are going to be eliminated. Oh, thank you.
Negative 2p.
Negative 2p, thank you. I can say that we're going to, it's pigs and chickens, I can't have hats and things happening in there. All right, 2p equals, what?
2p is 14.
Is all, okay, yes, all I did was drop that negative sign there. So p is 7. All right, so if p is 7, answer the original question. Go back. If p is 7, 7 plus c is 13, so c is 6, p is 7, and I would say always check in here to make sure you're correct. So is 4 times 7 plus 2 times 6 going to give us 40. 28 plus 12 gives us our 40. All right. So, wasn't too bad? All right, let's try the second one. Yep. Oh, thanks. I told my own students I would make mistakes, and that thing there makes me I feel very self-conscious. All right, so here's another application of systems. On the first day of ticket sales for the school musical, 10 adult tickets were sold and 20 student tickets were sold, and the school brought in $150. Next time the school only took in $37, they sold 3 adult tickets and 4 student tickets. That's going to be enough for us to figure out the price of an adult ticket and a student ticket. But let's assign our variables first. What is it you need to find out in the problem? Adult ticket and student ticket. So let's A, adult ticket price. And then S will be our student ticket price. So there's a lot of numbers floating around in there in that word problem. Let's just deal with the first sentence. 10 adult tickets and 20 student tickets got us $150. So what's my equation for that line? Ashley?
10a plus 20s equals 150.
10a plus 20s equals the 150. So there's what happened on the first day. Second day, now we're down to 3 adults and 4 student tickets. Of course, I used capital A's there. And that only got me $37. All right, think about using elimination. Think about which variable it makes sense of to eliminate. And tell me what equation you would like to multiply by something. All right.
Multiply the second equation by -5.
All right, excellent. If we multiply the second one by -5, you're going to get your s's to be eliminated. So 10a plus 20s equals 150.
Why?
And now my second equation, -15a
So that
minus 20s
you
equals
you'll end up
negative.
with negative 20s and positive 20s.
Negative
Cancel out.
165.
Oh.
Nope, I just did that wrong. Negative 185, I believe.
Mm-hmm.
So if I multiply by -5, that's going to cause the s's to be eliminated. So I'm adding the equations together now. Those cancel. 10a and a -15a gives me a -5a. Seems a little weird because I can't have a negative answer for an adult ticket price. But over here, -35. Oh, sorry.
No, isn't it? Isn't it? Oh, 85. I think so.
I did it first. I had
Okay.
So now our adult ticket is 7. So we almost have our answer, but we need the student price. So take your adult price, plug it into one of your equations, and let's get the student price. So you can plug into either equation. Again, it's supposed to work in both of them. So if adult ticket price is 7, 10 times 7 plus 20s is 150, so that's 70.
Whatever.
Yep, 20s has to be 80, so s is 4. Same thing would happen if you plugged it in here. If a were 7, 21 plus 4s is 37. Subtract your 21. 4s is 16, so s is 4. So s is 4, a is 7. And again, that's the only solution for both of those equations. They have to be charging you the same price both times. All right. Feel good? We're almost done. All right, and we're going to switch gears a tiny bit here. So catch your breath for a minute because I am going to use something a little different here.
What'd you say? Inequalities?
Remember we had to do that on the computer?
Yep.
That was in the beginning.
That was what?
In the beginning.
It was a while ago.
All right. That was your quick 60-second break. You ready? Here we go. That was it. We're on a time limit. Okay, so we're back to graphing. And in a minute, I'm going to show you a way that the computer could be used to do this. But again, I need you to understand what the computer is doing for you. Okay. So I'm asking you to now graph an inequality. Y is less than 2x plus 1. Right. So before we were talking about lines, y equals 2x plus 1, there's a set of points that work. They're on that line. But if I say to you, y has to be less than that, can you understand that sort of opens up a whole possibility of answers? Like a lot more than just a single line. So, but how you start this problem is you graph the line. This is sort of your boundary. So we're going to graph y equals 2x plus 1. So that, if that were the line, y equals 2x plus 1. But this is saying to us, y has to be less than that. So do the points on that line actually work in that inequality?
No.
No, so this is what we have to tell the reader of our problem. This needs to be a dashed line, because those points don't really work, but we sort of need that to guide us. Alright, so because this is less than, those points that work on the line don't work for the inequality. So it needs to have a dashed line. So because of that, we're going to have a dashed line. But now can you imagine that line sort of splits the coordinate plane into two pieces? We have to figure out, well, where are those ordered pairs that work? Easiest way to do that is just test a point. So you can test any point you want. Let's test something over here. 1, 2, 3, 4, 5. All right. Want to use that? 5, 2?
Yeah.
Let's plug it in and see. When y is 2, is that smaller than 2 times 5 plus 1? Is 2 less than 11?
Yes.
Yeah. And in fact, if you tested any point on this side of the line, these all work. So you end up having to shade that side of the graph.
Mildly.
All right, so take a peek up here. For those of you that have been playing around with GeoGebra, and I know that's not my class, but some of the other classes have been. If you graph that line, stay with me, guys. I know you've just digested a lot here. When you shade, like there's an infinite amount of points that work now. Just on the line, I know there's an infinite amount too, but can you sort of understand that there seems to be even more infinite amount of points over here? Because it's an inequality. So, and everything ends up being shaded on that side. All right, well now imagine, we talked about where lines intersect to get a common solution. Well now if you think about inequalities, where are they going to intersect? They're going to have to intersect in regions. So you're going to have to sort of look for the overlap. Right? So that's what the last example is going to look at. So fortunately I had you graph the same original line with a new inequality.